So in 1.4, we're going to be looking at perimeter and area in the coordinate plane. So if you want on the front cover to write your I can statement, it's right there at the top. I can classify and describe polygons, and apparently I put 2 periods because I don't know how to type. So it's not like a question, that's what it is. I can classify and describe polygons for 1.4. Alright, so in 1.4, that's what we're doing. We're going to be looking at finding the perimeter and the area of polygons and naming them when they're on a coordinate plane. So usually they're going to be graphed, or we graph them ourselves, and we find these things about them. So what is a polygon? In geometry, a figure that lies in a plane is called a plane figure. Recall that a polygon is a closed plane figure formed by 3 or more line segments called sides. Each side intersects exactly 2 sides at each vertex so that no 2 sides with a common vertex are collinear. Alright, whole bunch of mumble jumble, which means as long as it's a shape and they only meet with 2 lines in a corner, we've got a polygon. Okay? We can't have a shape with 2 lines because they would just be a flat line. So it has to have at least 3 lines, which would be a triangle. Alright, so the number of sides determines the type of polygon, or what we call it. So you probably know most of these. If it has 3 sides, we call it a triangle. If it has 4 sides, we call it a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. Do you get the point?
Why is there no 11?
Because we don't ever use an 11-sided shape. But that's a good question. Because you can't really do anything with them in nature. So, and then anything more than a 12, we just call an n-gon. So however many sides it has, gon. Okay? So what would we call a 6-sided polygon? A hexagon. What would we call a 14-sided polygon? So the n is the number of sides, so this would be a 14-gon. Whatever the number of sides is, that's n. So if it was a 64-sided shape, it'd be a 64-gon. Anything more than 12, we just put the number there. Alright, go ahead and flip the page. And we're going to look at the types of shapes we can have. Alright, a polygon is, let's see, what am I doing first? Convex. C-O-N-V-E-X, convex. When no line that contains a side of the polygon contains a point in the interior of the polygon. A polygon that is not convex is called concave. Alright, so here's what we mean by that. Convex means any line you draw along a side of it is never going to go through the middle. Concave means that at least one side, if not more, when you draw and trace that side, it's going to cut through the middle of the shape. So this was the first side that cut through the middle. Because when we extended this side here, we cut this little triangle piece here. Here would be another one. If we traced this side down, we cut through the middle of it again, or the interior. And I think that's it. The other ones are all going to stay on the outside. So for that one's concave for 2 different sides. This one, if you trace any of the sides, you're never going to get on the inside, so that one would be convex. Alright, so work with your table to determine whether these are convex or concave shapes. So if one of the sides, when you trace it, would cut through the middle, that's when you're going to be calling it concave. Alright, for the sake of my recording, this one was concave and convex. Alright, so perimeter and area. There's the formulas for the most common polygons. So the perimeter of any shape is all of its sides added together. So in a triangle, it's 1, 2, and 3. We add them all together. In a square, we can take one side and multiply it by 4 because they're all the same. Or you can just add it 4 times. I don't care. For a rectangle, 2 of the sides are the same and then the other 2 sides are the same. So we usually say 2 times the length plus 2 times the width. Or you can do length plus width plus width. And then we usually find our parallelogram the same way as a rectangle for perimeter, but the area is what's different here. This is the base times the height. Alright, and I think you know your area formulas for the other ones. The area of a triangle is 1/2 base times height. The area of a square is the 2 sides multiplied together, which is s squared. And then length times width for a rectangle. Alright. So it says we're going to find the perimeter on a coordinate plane or an XY plane. So on the PSAT, they don't usually call it a coordinate plane, they call it an XY plane. So I'm going to try to use those words interchangeably so that when you see XY plane on the PSAT, you're not like, what is that? Alright, so on the XY plane, first we're going to find the length of the sides using the distance formula. And then we'll add them up so that we can figure out what the perimeter was. So we have the coordinates for D, E, and F. We need to figure out how long each side is so that we can add them together. So which side do you want to find first? I don't care. DE. All right, let's find DE. All right, remember your distance formula. I'm going to write it up here so that you can see it. Distance is the square root of. Does anybody remember what that one was? Chloe?
Wasn't it x2 minus x1 squared plus x2 minus, y1? I can't speak.
I knew what you meant and I wrote it as you were saying it. The square root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so do we want D or E to be x1, y1?
D.
Alright, so x1, y1, x2, y2. Alright, you're going to find the distance of that side on your own because this is review for us now. So I did 671. Doesn't matter. You could have stopped at 6.7. Alright, so we did 4 minus 1, which was 3. 3 squared is 9. 3 minus 3 is negative 6. Negative 6 squared is 36. So 36 plus 9 gave us 45. And then you take the square root of that, which gives you 6.708 or something. So I rounded to 71. All right, find DE, or not DE, we already found DE. EF next. Here is my work. So 4 minus negative 4 becomes 8 squared. I messed up here, so ignore my squiggle. Negative 3 minus negative 3 is negative 3 plus 3. Negative 3 plus 3 is 0. 0 squared is 0. I gotta stop touching it. And then we get 8 squared, which is 64. The square root of 64 is 8. Yes. I don't remember what the answer is, but I can't be doing I think that's right. I don't remember. I've done this one a long time.
Yeah, no, it's like DF.
Oh, you don't have a plus sign. Alright, find the last side. This one you do need the distance formula because it's not on the grid. 0.8 is the one side.
7.8.
Alright, so when you found the last side DF, or FD, whatever you called it, doesn't matter. It was 7.81. And then we add all 3 sides together and we get 22.52, and then I just rounded to 1 decimal for my final answer. You need at least the 5, unless it says to the 100th, which it didn't say. Make sure you put units, since we don't know what this is in. This could be feet, miles, seconds, I don't know. It could be anything. Alright. On on to the next page once you have that. We leave here at 1:26. Alright. This is the last page we have to do, and there's only 2 questions on it. So it says we are now going to find the area of this shape based on the graph. So we have to find the length of the base, we have to find the height, and then we have to find the area. What type of shape is this? This is a parallelogram because the sides are angled. So let's find the length of the base. So which side do you want to call the base? Okay, this side here?
Yeah.
Okay, what's the length of that thing?
4 units.
4. Alright, now we need to find the height.
6.
So you go straight up from one of the corners.
5.
1, 2, 3, 4, 5, 6 units.
Oh, I didn't know.
Okay, the area formula was area equals base times height. Our base was what? Our height was what? So what's our area?
44.
And what's our unit?
Unit.
Units squared. Because now we're in the world of area. 24 units squared. Alright, you're going to work on this last one with your table. It says you are building a shed in your backyard. The diagram below shows the 4 vertices of the shed floor. Each unit in the coordinate plane represents 1 foot. Find the perimeter and the area of the floor. I used the formulas. So the area, or the perimeter formula was 2 times the length plus 2 times the width. And the area formula was length times width. So that. Alright, I'm going to give you the last thing. I don't think you'll finish it today, so we can wrap it up on Wednesday. But it's more midpoint and distance formula to wrap up our midpoint and distance formula work.